everybody, Mr. Balker here again for Career Explorations. Today we're going to go ahead and go through another little lesson. It is Unit 3, Lesson 2. What it's about is, again, manufacturing marketing, but this time we're going through a little bit different stuff, okay? It starts off with manufacturing, production, process development. A bunch of words that basically mean how we come up with what the heck we're going to do. So let's talk about some really good examples of that. First of all, the iPhone was an engineering marvel when it was created. And I mean, nobody had done anything like that ever. It combined so many things, the use of the touch screen, the fact that it had all the interactive apps that all talked together. It was brilliant. You guys, obviously, it is ubiquitous. It's been in your life forever. You've never known a world without it. But let me tell you, before the iPhone, the implementation of various cellular devices was almost comical. I was going through my stack of old phones just the other day, because I have some old phones, and it was just funny to me how the evolution went from junk, flip phone, finally something with a keyboard, finally something with a little bit better keyboard, to suddenly everything is that same exact shape, right? That rectangle with a flat glass screen that does everything all at once. And that was one big move. So why am I mentioning all this? Because that is industrial design, okay? Apple happened to have an extremely good industrial design engineer named Ives, who did a phenomenal job with the design of the iPhone to incorporate all those elements into one thing. It was unheard of. The idea was just crazy. That's a good job. If you like to design things, that's a really good one. Here's another good example. What if you want to design cars the way that they look, not the way they work, because that's a whole different thing. Mechanical design and aesthetic design are slightly different. So how do you design how a car looks? Well, this is actually pretty cool. First, the mechanical engineers tell you this is what you've got to work with. These are the dimensions that you've got. And then you get a big giant block of clay, and they will actually cut away the clay and shape the car to give it a distinctive look. And they've got so many things to look at with that, because not only do they want the car to look a certain way, but they also want it to perform a certain way. In the past, there have been examples of cars that were designed only for the way that they look and not the way that they perform, and they were disastrous. The cars would be unstable at freeway speeds. The cars would have parts that were inaccessible whenever you had to repair them, and it would be very, very expensive, challenging, and badly received by the public. And you can't have products badly received by the public because nobody buys them. So, what are these jobs? Industrial designers, drafters, engineering technicians, mechanical or industrial engineers. Okay, so here in this box it says, look at the things around you. Is there a computer, a notebook, a pen? Somebody had to design all those things. It's funny that they mention pen, because pens actually have design standards. A long time ago, whenever we were working on the first exploration of space and getting out into space, people were having challenges writing, because an ink pen has to be held with gravity pulling the ink down to the tip. Most pens don't write very well upside down, and they certainly don't write very well upside down for long. So they had to be somebody who invented something new. So this guy named Fisher invented the space pen. Now there's a really funny internet thing that I saw a while ago, that we spent millions of dollars developing the space pen, blah, 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 and it's a big waste of government resources because the Russians just used a pencil. Well, that's only kind of true. One, millions of dollars not spent developing the space pen. Fisher did this on his own time, and he sold them to us at a pretty reasonable rate. You can still buy one. Second, the Russians did use a pencil, and the downside to that is that pencils are made of graphite. I know we call it lead. It's not lead, it's graphite. What is graphite? Graphite is just pure carbon. What does pure carbon do when it floats around and gets caught in a circuit? It sparks, catches fire, and blows up a spacecraft. The Russians switched over to using the Fisher space pen. So if you ever happen to see that article, you can tell those people to do their research, because industrial design is extremely important. using the cheapest, most available thing in the world is not always the best idea. Sometimes a good industrial designer is going to change everything. The Fisher Space Pen, if you ever get a chance to see one and use one, it's really quite the nice pen. All right, so what do these people do? Well, they have to look at... Bells still work. Those people have to look at all of these various requirements. Okay, let's talk about the Space Pen again. What's it have to do? Well, it has to write upside down. That's a big one. It can't leak, right? You can't have droplets of ink just floating around the inside of a spacecraft. That would be terrible, right? It has to be easily handled when you have gloves and such on, because oftentimes in space you're going to have certain gloves on to keep your hands from drying out, et cetera, et cetera. So they have all these parameters that they set. They say, okay, well, how can we make this thing work best? And so they design it. So what kind of education is it near? Well, that's a lot, actually. If you're going to be a designer of stuff, you're going to need some education. Going back to the car thing, if you don't understand flow, if you don't understand aerodynamics, if you don't understand power to weight ratios, acceleration, these things are physics, chemistry, all of that. If you don't know those things, you might design a car that doesn't work right. If you don't understand airflow over the top of the car, pushing it down to the ground and keeping it planted, and instead you design the car so it has very little flow over the top and all the flow comes from underneath, you get what's known as an airplane. And the car that flies up off the ground and doesn't handle very well kills people. And that's a bad thing. And we actually had an example of that happen quite a while ago. But there was a car design that had no downforce whatsoever, and it ended up crashing because it didn't have any traction. Those are the things you got to know. So what kind of education are you going to need? You're probably going to need a 4-year degree, sometimes even more than that. You're going to need a lot of computer skills, okay? This stuff is all done on a computer these days, and then you end up fleshing it out in person to make sure it works. And the big one is creativity. If you're going to be somebody who's designing stuff, you've got to be able to see something that isn't even there yet. And I know that sounds like a cryptic statement, but the best example of that I've ever heard is somebody who's a sculptor said, I didn't carve the statue. It was always there. I just removed all the things around the statue. And I've always thought that was a brilliant statement, because somehow, and I've got friends that can do this stuff, man. I can't do it. But there's people out there that can look at a piece of wood and say, oh, that's a duck. And they can remove all the other parts that aren't a duck. And yeah, sure enough, it's got this really pretty hand-carved duck inside it. Takes creativity, takes vision. Okay, next section here, production. When you think of production, you generally think of the actual art, the act of building something. But there's way more to production than that, okay? Production can be a guy that works on an assembly line, a welder, a sewer, a factory manager. All of those jobs involve working in a building where you're making a thing, right? So again, I told you guys that I work with leather, okay? So one of the things that I like to make, it's a gift for nieces and friends and all of that. It's just this round barrette with a single wooden dowel that goes through it. And on the outside of the round barrette bit, I can stamp a design and make it, look like a basket weave or put initials or whatever. And, they're cutesy little frou-frou things that a lot of my younger cousins and siblings back in the day used to like. That's production. I start with a piece of square leather. I cut it out to the appropriate shape. I then treat it, stamp it, build my design, put the holes in it, fold it a little bit to give it a shape, put the stick through it, dye it the right color, and then I give it out as a gift. That's production, the whole thing. Is that very efficient production? Heck no. Assembly lines are efficient. If I was going to do an assembly line, what I would do is I would stamp out 85 of them in a row. I would build and jig and put the same design on every single one of them. Then I'd run them through there and I'd get 85 of the same thing. I'd have a punching machine that went whack whack and made all the holes. That's it. But I don't do that because I'm a one-man job and I'm trying to make it personal. I hope that makes sense. That is an assembly line worker. You do one task And sometimes it'll rotate. I told you about that car factory that will go through a number of different things, but that is production. Welders, I've known people that work on oil pipeline welding. They'll make parts for large vehicles, whatever. Welding is certainly a production gig, right? You're given a set of schematics and a design, and they say, hey, we need this thing. So you make it. That's all there is to it. Sewers, same thing, making quilts and such. So here they've got a couple of examples. Jared went to vocational school and learned to weld. He works in an automotive plant and assembles the frames for vehicles now. He likes his job and he's hoping to become a manager. That's something a welder can do. Automotive plants now use a lot of robot welders, but there's a lot of other places that don't. A good example of that is I've got a friend who is getting into the business of building custom barbecues, right? These big, heavy steel smokers, and he's got to roll the metal, weld all the joints, make it perfectly airtight so that it produces a really good smoke so that we can have delicious cooked meats. That's a job that is in production, welding like that. And again, it can pay pretty well. Specialty welding, you don't have a lot of options. It's not like you or I can just say, all right, let's weld this up real fast. No, you can't. Somebody who is a welder can weld it up because it's a skill, and it is an important skill. Christina has a bachelor's degree in industrial design. She works for a small appliance company. She might have designed your blender or toaster. Yeah, that's industrial design, guys. We talked about the iPhone, but everything has an industrial design. This monitor right here has a certain design to it. That goofy keyboard down there has a design to it. Somebody, somewhere said, okay, here's what we want it to look like. And they laid it all out and made it cool. That's a neat job. That also, however, does take a lot more education. Third one, this is an important one. They talk about quality assurance careers. What's quality assurance? It's making sure stuff works right. Again, the car I talked to you guys about earlier that, took off like an airplane. Very low quality assurance in that one, okay? You want to make sure that the car stays on the ground because otherwise it's not going to work well. Same thing's true of bridges, buildings, chairs. If you build a chair out of cheap, lightweight metal and you don't weld it properly, the first time somebody sits on it, it's liable to break. And if it breaks badly enough and suddenly enough, somebody might get hurt. And when that somebody gets hurt, one of the lawyers is going to sue you. And it's going to be your fault because you didn't design the thing right. You didn't quality test it. So that's what quality assurance people do. A good example that they give down here in the text of a quality assurance thing that went wrong is the Deepwater Horizon well. What's the Deepwater Horizon well? It's an offshore oil well. So, out in the ocean, they will drill a very big hole and they will extract oil from underneath the seafloor. It's very effective and we need oil to build things with, but there are some inherent risks. Specifically what happened with this one was the concrete around the bottom of the well that seals it ruptured. And a lot of pressure came out really fast. It overloaded a safety valve, which then forced a ton of oil to spaces it's not supposed to be, and then got caught by a spark, and then exploded, killed like 11 people, I think they're saying, and it spilled 4 million barrels of oil all over the inside of the ocean. Now, it didn't end up being as bad as we were afraid because the oil seemed to kind of sequester itself, but when you think about 4 million barrels of oil being spilled all over the place, that's an ecological disaster. Tons and tons of plant life and sea life died, and all because they didn't check the concrete properly that sealed the bottom of the well, which allowed the pressure to build, which had everything else go wrong. Quality assurance is an important thing to do. What skills need to do that? Well, the most important one, attention to detail. If you don't have attention to detail, you don't notice that the concrete's not done right, and it blows up and dumps all kinds of oil all over the Gulf of Mexico and kills 11 people. That's a bad situation. So attention to detail is a really important one. That's it. That concludes this lesson. I hope you guys enjoyed it. I will see you again for the next one very soon. Thanks so much.